My name is Oliver Kingsmith, and I'm the founder and CEO of smartR AI. And I started working with AI 9 years ago when I was actually working with Toyota on a product to help blind people navigate in indoor environments. And in fact, it was my first introduction to how important data is when you're actually doing AI and machine learning. We held a contest inside Toyota, which is an enormous organization, where you could win $5,000 in a random draw if you submitted 3 photographs or more from shopping malls in your area. So by the end of the week, we had a huge data set. And we started training our models on it, and everything was working really well. And then we went out and actually tried it with some blind people in the malls. They had this little necklace on and cameras, and it could see. And what we quickly found is that blind people navigate by staying by the wall, which makes total sense. It restricts their degrees of freedom. But of course, we'd trained all these images where people walk out in the middle of the mall and take pictures. So none of them were getting recognized by our models. So we had to go back and retrain. I think the other thing I learned is if you can't get your logo recognized by a simple model, you should probably change your logo. So data, that's what we're talking about tonight. And this number on the screen represents the amount of data that is going to be collected and processed this year. And this is an incredible amount of data. If you turn this into dollars and distribute it evenly among every man, woman, and child across the planet, we'd all be richer than Elon Musk. And yet, in many ways, this is a small number. In this room tonight, in all our cells with all the DNA, there is more information than's represented in that number. So this number is only going to grow dramatically over the next 20 or 30 years. So this gets us to the heart of what we're talking about tonight, and that's really data and how do you get it prepared when you're going to do machine learning or AI. Now, I've been to so many conferences where everyone always says, oh, you've got to clean your data first. That's the first thing to do. And we tell people, don't. You're going to waste your time. What you want to do is actually identify your use case that you want to solve, and then you want to clean up the data that you need for that use case. And there are a number of reasons for that. So the first one is that data needs to be somewhat balanced when you're training your AI models. So if you have 100,000 examples of cat pictures, but only 18 pictures of hamsters, you can't use all those cat pictures. They're just going to be wasted if you clean them all up. Likewise, you're going to have to, when you're actually classifying and trying to clean up your data, you can use AI to help you do that. So instead of waiting to use AI, start getting AI involved early in the process to actually help you clean your data up. And in particular, AI is very good at having uncertainty, and we'll talk about that in a second, what that means and how you can use it. Another big problem you're going to have is missing data. This is endemic in a lot of medical data. We're going to actually look at an example in manufacturing tonight where there was a lot of missing data, in warehousing there's a lot of missing data and how we actually solve that. And then you also need to categorize examples that you're going to train your model on. And those categories are not necessarily obvious until you know exactly what problem you want to solve. And then free text, everyone has it, huge amounts of it in organizations. We estimate about 70% of the information inside organizations are in free text forms. And we just couldn't get access to that or do stuff with it until these advanced LLMs came around. So with that, I want you to kind of think about how you're going to use AI to actually help clean up your data. And I mentioned that AI is really good at uncertainty. You can actually ask AI how confident it is. So with a large language model, for example, you can actually prompt it and say, how confident are you in your answer? And it will give you an actual number. It will actually spit out a number. And while the AI models are a little bit like Americans, they're overconfident, it will give you a directionally correct number. Like if it's extremely confident versus I'm somewhat confident, you can be guaranteed that that somewhat confident is something you look at closely. But you don't need to do that just with large language models. You can do it with, say, simple classifiers if you use dropout and then rerun the classifier several times and see what the result is. Or in autoencoders, you can, especially variational autoencoders, you can see what's going on in the latent space, and that can give you an understanding about how confident the model is when it's trying to classify or identify information in your data. So with that, I want to look at a number of examples tonight. These are all real-world examples that I've chosen that we've worked on at smartR. This first one is in manufacturing, and this is a really common problem that we see. We had a client come to us with these microfluidic chips, and these get used all over the place in medical and scientific research, and they get turned out by the hundreds of thousands, millions, probably actually billions a year. And the manufacturing process for it's really good. You know, they get very, very few failures. Maybe 1 in every 10,000 units has a problem. And when it has a problem, it's quite subtle. It's hard to see it. In fact, there's a problem on this particular chip, and it's pretty hard to see where it is if you look at the chip. So this is a very unbalanced data set. So how do you deal with that? So the way that we dealt with it is we trained an autoencoder across a few 100,000 images. And then we looked at the handful of bad examples that went through that autoencoder. And we could identify in the latent space, if people are hopefully familiar with latent spaces and autoencoders, we could identify where the bad images were. You can do things then to say, okay, we've grouped them in that latent space, and we were lucky they were grouped. But you can also use techniques to force bad images into a particular part of the space if you need to. And there's quite a lot of literature out there on how to do that. And then the most important thing when you're actually using this in production is to define a smaller good space, not the bad space, but the good space, so that if anything falls outside of the good space, you flag it to go for inspection. So when we did this, we could actually reduce the number of images they needed to look at by 100 times. So instead of looking at 10,000 to find an error, they can now look at 100. And the QA results went up because the QA people were not as fatigued as what they were. The next example I want to look at is missing data. And this was a client that came to us that does a lot of stuff with warehousing. And in warehousing, they're helping actually improve and optimize the way that warehouses operate. So they're constantly getting in new data from their clients all the time that they need to analyze. And it's missing data, and it's missing kind of important data. Typically, it has very incomplete data on things like the size of what they're actually moving in the warehouse and the weight, which you think was kind of critical information, but it's frequently missing. So we built them a pipeline where we actually had a whole bunch of standard questions, and they could actually add more questions to it in time, that would then go in and query the data and produce a nice standardized output so they could at least see what they were dealing with when the client sent new data over. And then we actually then built another pipeline for them after that, where we'd go out and we would scrape the web to try and find the information to populate all the missing data about the products that were in their warehouse. That often means we have to look at PDFs, and that is a constant pain point. So if anyone out there has a really great PDF parser that's guaranteed to work offline, come up to me, because I'd love to know about it. And then what we did was built a sort of a sanity model. Like, does this value make sense? Is it possible that this Pikachu plushie really weighs 3 tons? Or is that something that's got scraped in correctly? And then we then could have to have another model that we actually created that allowed us to estimate not just the product weight and size, but what was it in its actual shipping form, in its package form? How much extra weight, how much extra size is that likely to add? Because that's what warehouses actually are interested in. Another example is handling messy data. This was a client that came to us and asked us to try and figure out what was happening with cancer patients in the National Health Service. And they had this data set they wanted us to look at, and it was 7,000 tables. It had 400 different schemas in it. And it also had these non-aligned identifiers between the different tables. So it was a real problem for us to actually deal with this. So what we did in this particular case is used AI to help us understand what was the structure of the data, to actually document that data. And we used the uncertainty in the AI to flag tables and columns in those tables that it didn't understand, so we could go back and work with the client to correctly document this enormous data set that they had. And then using AI again, we generated SQL code that allowed us to actually match up these identifiers between different tables much more effectively than trying to write it by hand. And this allowed us to answer the question that they were interested in less than a week, where when they came to us, they figured it would take months to actually get an answer out of this messy data. And then the final one is actually an aerospace company that we're working with right now. And this is a good example where you don't want to try and classify your data before you know what you're looking for. They have around 500,000 items that have been returned to them over the course of the last 15 years. And they have to fix it and they have to document it because they're in the aerospace industry. And one of the questions that came up recently is, do they have a switch problem? Is one of their suppliers of switches sending defective stuff to them? And they want to know how many things were switch activation errors that they had. And that could get coded by the technicians all kinds of different ways. They might say the button was defective, or they might say that the key didn't work, or all these other different ways of actually saying it. So what we did for them is we've built them a model that actually allows them to take a natural language input, like which models have had key activation failures of more than 1% over the last 6 months. And it will go through and pull everything out of their database using SQL as far as it can. And then what it will do is actually use large language models to look at all the free text of the remaining fields and classify them. And it will classify them, this was a key failure, this wasn't a key failure, or once again, that uncertainty, I'm not sure whether this was a key failure or not. And then rerun the SQL across that new table with the extra column in it and be able to pull out the information. So hopefully I've given you a sense of some of the real problems that you have with data in the real world. You're going to spend a lot of time if you're building machine learning models or doing stuff with AI actually cleaning up data. It's maybe not a glamorous part of the job, but it's a really important part of the job, and you're going to spend a lot of time doing it. And I hope tonight I've shown you that you really want to clean once you know exactly what you want to do, and you can use AI to help actually clean it up. I've put my contact information up, so please feel free to get out your cell phone and scan my QR code. And if you want, you can also reach me on the side. I'm happy to talk about any problems you have in AI. Thank you so much.